When we have learned the concept of random variable, then we have seen there are two kinds of random variables. One is discrete types and another one is continuous type random variable. So similarly for as well distributions. So to represent a random variables, we use the distributions concept that we have learned in previous lectures. So to describe the random variable, we use the concept of a distributions concept. So similarly, the distributions are also two types. So one is discrete type and another one is continuous distributions. So now let's discuss one by one. As well, in previous we have already discussed the Gaussian normal distributions. That's the one kind of continuous distributions. To see the main differences of differences between the discrete distributions and the continuous distributions. So for continuous distributions we have called the probability density functions. So for continuous distributions we have called the functions the probability density function. And for discrete random variable, we call the distributions are we represent the distributions for a discrete random variables through a probability mass function. Probability mass function. So both the same thing, for just we denoted these things. So for continuous random variable, these are the random variables. For continuous random variable, we elaborate the distributions through a probability density functions, and for a discrete random variable we will elaborate, we denote it the distributions to a probability mass functions. Okay, I think if you had taken an example to discuss this theorem, to discuss this concept, then I think this will be better for us. So suppose let's discuss first the discrete random variable, discrete distribution. And we apply to explore the discrete distributions through the probability mass function. In short, probability density functions. In short, we have written the probability density functions PDF. In short, probability mass functions we should written PMF. So now let's discuss. So taken an example. Suppose let's take we are going to experiment suppose let's take we have defined and we have going to experiment to throw a die. Throwing a die. So in this experiment, and there have 6 outcomes. So this experiment X can be represented by through the 6 outcome. It will be 1, 2, 3, 4, 5, 6. So if you see these things, the outcome of a random variable here is discrete. So the outcome, such kind of random variables is called the discrete random variables. I think we have understand the main differences between, don't be confused, the what is random variable and what is distributions. So random variables is simple an experiment that is represented by the outcomes of that particular experiment, and the distributions are that explore that or elaborate that define that random variable. That things are called the actual distributions. This is the differences between the random variable and the distributions. So random variable simple an experiment, and the distribution is the technique that describe this random variable. So here we got the outcomes of the random variables is in discrete manner. So because of that, this random variable is called the discrete random variable, and the random variable then the way that describe that random variable is called the discrete distributions, and the mathematical function that describe these distributions is called the probability mass functions. This is the relations. Okay, so in these examples, so if we taken a pair die, if we taken a sample a pair die, if we simple taken a pair dice, then the probability of each outcome is equiprobable. So the probability of x is equals to xi, sorry, don't, x is equals to I sample, it will be 1 by 6, because how much point it will have? There have 6 points, 1 2 3 4 5 6, and for throwing a die we got only 6 outcomes, so there are total 6 points. So because of that, we have taken here a pair dice. So of this random variable, its outcome will be, the probability of each outcome will be 1 by 6. Here I is running from 1 to 6. 1 to 6. This is the probability that we have got from that experiment. Okay, and if you just plot this thing, if you just plot this thing for this experiment, so let's draw the pictures of this thing. So suppose let's take the x-axis is our random variable x, and the y-axis there are going to draw the probability mass functions. If we draw these things, so they have 6 outcomes. So I'm taking different color. So this is the first outcome 1, this is the second outcome 2, this is the third outcome 3, this is the fourth, this is the fifth, and also this is the sixth outcome. So here we have the h equal probable equiprobable. So the h probability, if we take on that from 0, here is 0, it is 1. So the h probability equiprobable. So this probability is divided by 1 by 6. Suppose let's take 0.5 and 6 like laid here. Suppose let's take it's the 1 by 6. So the our point, if you just draw these things, for 1 probability 1 by 6, 2 it will be 1 by 6, 3 it will be 1 by 6, 4 it will also 1 by 6, 5th is also 1 by 6, 6th it's also 1 by 6. So this kind of picture we will get. Okay, this kind of pictures we will get. So here we got the 2 parameters. So just see these things. If we using this technique to our calculations, we need only 3 parameters. So let's see step by step, so that we want to calculate these things. So we need here the 3 parameters we need. So first is on A, second is called B. So let's take what is B actually. B is simple, the point, that's the first point, that's our outcome of the experiments take. So here experiments take the 6 values. The first outcome is what? 1. So it takes 1. And the B is the parameter That's take the last outcome of our experiment. So what will be the last outcome? So here the last one is 6. So B6 the 6, and n, the n is the number of outcomes, the third parameter that we need to our calculations. N is the number of outcome, number of outcomes of the experiment, the experiment means, simple experiments means that we call the random variable x, number of outcomes. So if you just count these things, if you just using these things, O, A, B and C, so what will be the relations between them? The relations between them will be the number of outcomes will be counted by A plus B, B minus A plus 1. Actually here we have taken the outcome, the first outcome is 1, the second outcome is 6. So the outcomes are relations between the outcome and the relations between the outcome and the number of outcomes. Okay, it will be this. So here n will be what? 6 minus 1 plus 1. That will be 6. And the probability will be, probability for the discrete random variable be 1 by n. The first thing that we have to remember, the age outcome on this formula will be workable. This formula will be workable only when our age outcome will be equiprobable. Okay, that's the first thing that we have to remember. Age outcomes will be must be equiprobable, first thing. And the second thing is that, and the point, if you just consider this thing, suppose our outcomes will be, you can say the maybe our outcome will be, so our outcome will be 1, 3, 6. So how much point we have here? First point A is equals to 1, last point B is equals to 6. If you apply this formula here, n will be what? N will be 6, but number of outcomes here is 3. So it is totally different. Because why it is totally different? Because why? Because here number of outcomes is equals to 3. But the main problem is that in such scenario, it is not equiprobable. Means if you take these events, equiprobable means in what sense? You can say our main random variables x. Suppose let's take we can and draw a random variables, that's the number of even point on that experiment, a number of even point. Okay, number of, if you take the number of even points, then it will be 2, 4, 6. Sure, but the probability of 2 is equals to 1 by 6. The conditions all are okay, everything can say holds, but the main problem is the main problem is number of points in that we have no count. So in such scenario, if you just consider the x is equals to number of odd point, even points, so in such scenario it is not workable, because x is the primary random variables. On these random variables we will define the sub random variables. So these things will workable on the primary random variables, means it will be properly discrete. Okay, just if you omit these things on that point, it will not be workable. So I think from these things, uniform continuity, discrete uniform discrete distribution concept is clear. So this formula only workable on that situations, that this is the main, that means from that point to that point it will be properly discretized. I am not taken here any sub random variables. I think you have got the concept of the sub random variable, main random variables. So this is the thing. So these things, if our points are properly discretized, then only that things you will got that kind of answer. Okay, this is the I think from that, if you have any problem, please just read these things on the Wikipedia article, then you can got a or more details concept. I think from that concept you got the idea how these things are doing. So this is the concept of the discrete distributions. Now in second, we will learn the continuous random variable, continuous distributions. Continuous distribution. So let's see what is actually this thing. Continuous distributions means here I am continuous uniform distributions. It is the discrete uniform distributions. It is the continuous uniform distribution, uniformity. So in such scenario, just if you see these things here, if you just see this thing, number of odd point, number of even points on that experiments, here we not got an uniformity. Here we not got an uniformity. So if you just take on this point, and this point, here this not maintain the uniformity. So in such scenario, if our distributions is not uniformly distributed, then in such scenario we cannot apply this formula. Only when our distributions is uniformly distributed. Okay, uniformly means it's workable on mainly not workable on our sub-random variables. It's workable only over the main random variables. Okay. So now comes to the concept of the continuous distributions. So continuous distributions, the same concept is applicable also for continuous distributions. So suppose let's take I am going to doing an experiment X, whose first outcome is equals to A, and its last outcome, let's take its last outcome, is equals to B. In such scenario we cannot count. In this case we can count how much point we have, 1 2 3 4 5 6 by using this thing, n is equals to b minus 1. But here we cannot count the thing. So here the number of outcomes means number of observations. Here the number of observations will be how much? Simple b minus a. Here the number of observations will be simple b minus a. Okay. So in such scenario, our probability will be the same concept. Probability will be 1 by n, the same thing, but the pictures will be different. But the output pictures will be different. If you just see this thing, the picture will be totally different. You got the continuous random variables, our pictures will be this kind. Suppose it's the A, it is the B, and it's supposed to take its 1 by n. So first point will be here, last point will be here, and total this point. So because our in this range A to B, there have any points in on this range, we don't know, means it is continuously distributed on this range, but here it is discretely distributed on this range. Okay, but here it is the continuously. So this is the main differences, continuous random variables and the discrete random variables. The same things also applicable here. So it's denoted by through a integer value or through an integers value a and b. Here it is denoted through n and real values. So here in continuous random variables, and the value of the x, that value will be taken any value between a and b, and here the value it's taken in discretized manner, in integer value in that range. This is the main difference. I think you got the answers, the real numbers and the integer numbers. Means on that range we discretize this thing, but on that range we cannot discretize it. It could be taken any value. If you taken the examples, the true and dice, here if you taken the examples, the true the height of a student, such kind of that thing. Another thing that we have to remember, if you just draw the pictures of the CDF, means cumulative distributions function of random variable. If you just draw these pictures of the if you just draw the pictures of this PDF in CDF manner, suppose let's draw cumulative distribution functions of this continuous random variable, then how much points? Here let's take A, here let's take B. So in this range we got such kind of CDF functions. In B it will be 1, and after B it's take one value. Let's take 1. I've taken here different color. Let's take first, and before A it's 0. Let's take 0. Before A it's take 0. After A it will be linearly increased, and after that it's take the value 1. Let's take the value 1. But here if you draw the if you just see, but here if you draw the CDF, cumulative distribution functions of the discrete random variables, it will be take the pictures like that. CDF, cumulative distribution functions. So here let's take A value, here let's take B value. So before A its picture, suppose let's take it's the 0. So first how much point? 1 by 6. Suppose let's take it's the 1 by 6. Yeah, 1 by 6. Before A it takes the 0 value. Before A it takes 0. After A, at that point, after A, at the point, means I'm taking over this A, this is the B. Okay, and this is the another point, this is the another discrete point, this is the another discrete point, this is the another, suppose like that, or discrete pointer appear like that, here. So at before A it takes the value 0, and at the point A it's take the probability value 1 by 6, means 1 by 6, means 1 to this point. I think it will be better I have not taken just A and B, I'm just taken the 1 2 3 4 5, then I think it will be better for understanding us. 1 2 3 4 5 6 I've taken here. Okay, now if you just draw the first this one, it takes the value 0, and at the first point, at one point it takes the probability value 1 by 6. So 1 to 2 its value will be 1 by 6, just like that. And just 2 point, on the just 2 points, this value will be 1 by 6 plus 1 by 6, means it will be 2 by 6. So the 2 by 6 means its value will be, suppose let's take it's the 2 by 6 point. 2 by 6 point. So its value will be like that, 2 by 6 up to 3. Similarly, its value at the point 3, just on the at the point 3, its value will be 3 by 6. Just at the point 4, its value will be 4 by 6. And just at the point 5 to 6, its value will be 5 by 6. And 6, its value will be 6 by 6, means 1. Suppose let's take it's the value. Here the value is 1, like that. Here is the value 0.1, like that. So just before 1, its value will be 0, and just at point 1 to 2, at 1 to 2 point, means on this point there have no any outcomes. Just at 1 its carry will be 1 by 6. At 2, just at 2 its value will be 2 by 6. At 3, just sum of these things. Cumulative discrete functions mean the summed of all the points, all the outcomes. Okay, this is the simple formula of the cumulative distribution functions. Already in previous lectures we know these things. So the simple formula will be, these things will be, if you just take the formulations of the cumulative distribution functions, cumulative distribution functions. Okay, so these things will be, suppose let's take A will be our first outcome, second outcome will be our A plus 1, third outcome will be A plus 2, dot up to the last outcome is b, and the before last outcome it will be b minus 1. If this is the set of outcomes, if it is the set of outcomes for a discrete random variable x, this is the discrete random variable x, this is the outcome of the discrete random variable. So in this point, suppose let's take, I am calling this set is equals to k. This is the k actually equals to, let's say, means this k actually call the support of that random variable x. This k actually called the support that support this random variable x. This is the random variable x, and this k is called the support, and this is the outcome of that random variables. So the probability mass functions PMF in small letter we have written PMF. So PMF for these outcomes will be, they have n number of points. Suppose let's take the number of outcomes each n. Suppose let's take the number of outcomes. The number of outcomes. So the PMF, probability mass functions, will be 1 by m, 1 by n, means probability of x is equals to I, and it will be 1 by n, where I is lies on the set k, in the support set k. This is the simple PMF. Now the CMF, cumulative distribution functions. For this PMF, it will be the k value. I think I have the small k value. I will discuss step by step everything. Minus a plus 1 by n. So this k value will be now here. This k actually will be the point on that set. That point on that set means how much point actually we have. How much point we have. Suppose let's take just taken through the examples. Just take through an examples. So here how much point we have. Suppose if you taken this experiment through a die. So through a die, through a just if you taken an examples, the throwing a die. Okay, just if you taken this example, throwing a die. So in that examples, so n will be what? N is equals to 6, a is equals to 1, and k will be any outcome. A means simple, k will be, it is the small k, don't be confused, it is the small k. That's the point of the support sets. It will be capital K in support. That's the support. Okay. So n is equals to 6. At that point, if you taken this n is equals to 6 and k is equals to 1 on the through a dice, if you taken that experiment, here k will be any one value. Suppose let's take, I have taken here the k is equals to 3. I have taken here this k is equals to 3. So what will be the CDF of that point? The CDF of that outcome 3, it will be 3 k. K means what? 3 minus 1 plus 1 by 6. So what this will be? This will be 3 by 6. 3 by 6 means what? CDF means PDF of 1 plus PDF means 1 is PDF of the outcome 1 plus PDF of the outcome 2 plus PDF of the outcome 3. That means the CDF of the 3. So these things will be 1 by 6 plus 1 by 6 plus 1 by 6. That will be a 3 by 6. I think you have got the concept how this formula are workable on the scenario. This is for the discrete cases. Just if you taken the same concept in the continuous cases, if you just you apply the same concept in the continuous cases, and one thing that I have to remember, the mean of that support vector, the support set. The mean of that support set here will be the mean of that support set. It will be what? So the mean will be here A plus B by 2. Similarly for median as well, medians is also A plus B by 2 for the discrete cases. Now come to the continuous random variables. What will be the? So in continuous random variables, so X is not like a discrete set. So here support vector X in support set, support not vector, support set. Here support sets will be any value on that range A and B will be any value, means the member X, small x, that's the member on that support set, will be any value on that range. So on such scenario, our PDF will be our probability density functions, means PDF. Here PMF, probability mass functions. Here PDF will be what? 1 by B minus A, that we have already seen. So here for what? For X, for the point that's lie on this range, for value X that's lie on that range A to B, and it will be 0 elsewhere, and this will be 0 elsewhere. Means this formula means what? This formula means if you take on here in this range, in this range, and in this range, in this range and in this range, it will be 0. That means, and if you take on on that range, it will be take the value 1 by n, means 1 minus 1 by B minus A, this value. Okay, and the CMF, what will be the cumulative, what will be the CDF, cumulative distribution functions of that? What will be the cumulative distribution functions of this PDF, continuous random variable? So this will be the sample, this will be the 0, or if our X is less than A, it will be A is 0. Just say this thing, it will be 0 for if our less than is equals to, if A less than is equals to, X less than is equals to A, and sorry, it will be 1. It will be 1 for X greater than B. It will be 1, and on that B it will be linearly increased. Means if you just calculate this function, these functions will be X minus A by B minus A. B minus A. So this value will be for A less than X less than equals to X less than equals to B. This function, this will be the samples. At the end, just if you simply put the output of that outcomes value of that functions, you can easily got that CDF function. And you can easily calculate it how much point lie on that range, and that everything's also we have seen in the previous discussions. So I think you got the concept of the uniformity, of the uniform distributions. And in these uniform distributions are mainly used to generate the random variables on a range. We will see these kind of things, but I think from these lectures we got the details concept and how much parameters we actually need to calculate the discrete random variables. So what is the actual main differences of the discrete random variables and continuous random variables, and what is the difference of a random variable and distributions, and what are the actual uniformity, actually called the uniformity, these things, and how much for and what kind of formula are applicable here. I think that's kind of things you got the idea from that lectures. Okay, although you have any problem, please go to the Wikipedia, just search on the uniform distributions, then you can find the details of that article, of kind of things. And there have also available many articles, you can learn these things. And we will see in the next lectures, and how to generate the random variables, how to generate a random set of data from the use of these kind of uniform distributions. Okay, we will see this kind of thing in the next lectures.